In this video, we'll discuss the ways the government can interfere with a perfectly competitive market and distort the equilibrium quantity and price level that would otherwise exist. The learning objectives are 1. For the student to understand the effects of price controls. What happens to a competitive market when a government says you are legally no longer allowed to charge whatever price you want. 2. How taxes affect prices and quantities. And here we're only going to look at taxing the goods or services that are sold in markets. 3, we'll ask the question, does it matter if consumers or producers are taxed? And you should understand the answer to that question, whether or not it matters and how it matters. And lastly, you should understand how the tax burden is split between consumers and producers. And that's going to tie into learning objective number 3 a little bit. And here we're going to define tax burden as being how much more you're paying as a consumer because of taxes, or how much less you're receiving as a seller because of taxes. Well, let's start with price controls. Every time we have a spike in gasoline prices, you always see news clips of reporters interviewing angry people at the pump, typically early morning on their way to work, and saying, hey, what do you think about this price increase? Do you think the government should limit how much they're allowed to charge you? To which they always find somebody to answer, yes, they should. We should not have to pay this high price of gasoline. Well, it's something we've done before in the United States, and it's something that's often proposed, not just for gasoline, but for things like drug prices. Well, let's see what happens to competitive markets if we were to impose a price ceiling, which is a legal maximum that any firm would be allowed to charge for a given product or service. What if the government proposed a $5 a gallon price ceiling on gasoline, meaning that no gas station would legally be allowed to charge you more than $5? Now I'm going to be showing you some graphs that I've made with actual functions, and it'd be good practice for you to solve these on your own and check the numbers. So for your reference, I'm going to be using a demand function of P equals 10 minus 1/2 QD. I've even solved it for P so it's easier for you to graph. And the supply function I'll be using is P equals 1/2 plus 1/4 QS, or quantity supplied. If you take those two functions, that supply and demand, and solve for equilibrium, you should be able to graph this solution. The equilibrium price you should get is $3.67 a gallon, and the equilibrium quantity is 12.7, which, maybe we're talking about millions of barrels or gallons or whatever the units are. The number will be 12.7. Okay, so this is what we would get in a perfectly competitive equilibrium with many buyers and sellers and no government interference. But what if the government were to come in and say you can't charge more than $5? We can represent that with this horizontal line, indicating that no matter what, you can't charge more than this price. Well, in this market, it wouldn't really matter, would it? Because we're not charging $5 or over, we're charging $3.67. So this is what we would call a non-binding price ceiling. That is because it is a price ceiling, it is a legal maximum you can charge in a market, but currently it doesn't change anything. You can see I've labeled where it touches the demand and supply curve. You could see how it could cause a problem. If the price were $5, consumers wouldn't be demanding 12.7, they'd be demanding 10, but the suppliers would want to supply more, they'd want to supply 18. Whatever the units are, millions of gallons, whatever. And so that wouldn't be an equilibrium. But again, it doesn't matter because we don't get to that point. The market will go to $3.67 a gallon and sell 12.7. Okay, well, what if the government set a price ceiling that was below what the market would naturally be at, which is $3.67? What if the government said you're not allowed to charge more than $3 a gallon? I know a lot of us right now just hearing that would think, yeah, I can get on board with that. That sounds good for me. Well, let's see what would happen. What if the maximum price were $3 a gallon? Let's see. Well, in that case, as you can see, the price ceiling would be binding because we can't go above $3, which is where the market would naturally want to go. In this case, if the gas stations were not allowed to charge more than $3 a gallon, they would only supply 10 million gallons of gasoline. If the price were to drop to 3 by legal mandate, us consumers of gasoline would demand more, of course, because it's cheaper. We would be demanding 14 million gallons. But when you show up to the gas pump, there would only be 10 million available, meaning we'd have excess demand. Not only that, the total number of gallons that were exchanged went down. We were consuming 12.7 million gallons. Now we're only consuming 10. So those people who got the 10 million gallons are paying less, and I'm sure they're happy for that. But there's 2.7 million gallons that are no longer being transacted. And we have additional people demanding gasoline since it's cheaper. The total demand is now 14 million gallons. So let's investigate what effect this has on welfare. Now before the price ceiling, this is our situation. This was our equilibrium. The consumer surplus was represented by that triangle, labeled with a CS, because the demand curve shows us the maximum willingness to pay for each one of these units. And even though consumers were willing to pay different amounts, each consumer only paid $3.67 a gallon. So the difference between what was actually paid and the willingness to pay is the consumer surplus. Now if we add that up across all 12.7 million gallons, we get this entire triangle, which represents the consumer surplus in this market. Likewise, the supply curve represents the minimum willingness to accept. This is the minimum you have to pay the gas stations for them to produce that quantity of gasoline. And as you may learn in another video, this is essentially because the supply curve is representing the cost to the producers. So for example, if it cost me $1 a gallon to have it available for you, I have to receive at least $1. Now, even though the supply curve is upward sloping and there are different costs or willingness to accept for each gallon was sold for $3.67. So whenever the price was greater than the cost of that particular unit, or the willingness to accept, that is a producer surplus. Now if we add that up across all 12.7 million gallons of gasoline, we get this lower triangle, which represents the entire market's producer surplus. And taking consumer producer surplus together gives us what we sometimes refer to as total surplus or total welfare for this market. And we can calculate these numbers. So the area of a triangle, if you remember from math class, is just 1/2 base times height. So looking at the consumer surplus, we can think of the base of the triangle as being 12.7, the height as being whatever the difference between 10 and 3.67 is, whatever this line is. So we take those two numbers multiplied by each other and multiply by 1/2, we'll get the area of that triangle, which will be consumer surplus. Likewise, for producer surplus, the base is 12.7. The height is the difference between 3.67 and the intercept here, which was too close to 0 to be labeled, but that's 1/2. You can see that from the equation I gave you at the beginning. And we'll multiply those two numbers together and then by 1/2 and get the area of producer surplus. So here I've written 1/2 times the height, which is 10 minus 3.67 as we discussed, times the base, which is 12.7. And since that height is in price per units, and the 12.7 is in millions of gallons, we're assuming, when we get 40.2, the units on that are millions of dollars. Now, I didn't write any of the units here to keep it clean, but that's essentially what we're getting here is $40.2 million of consumer surplus, which means, in words, that all the consumers in this market feel happiness equal to the same amount of happiness had you simply distributed $40.2 million to everybody, because the value of the gasoline they consumed to them was worth that much more than what they paid as an entire market. Well, what about producers? Before the price ceiling, the producer surplus was equal to the lower triangle, which is 1/2 times the base of 12.7 million gallons times the height, which was the difference between $3.67 and 50 cents. Again, that 0.5 wasn't on the graph. It was too close to 0 for my software to label it, but you can see the 0.5 in the equation I gave you, the equation for supply. Calculating that, we get $20.13 million of producer surplus. This means that the producers received, in total, as a market, $20.13 million more than they had to produce those 12.7 million gallons of gasoline. So this is their surplus from doing so. Now, taking a look back at the situation where we have a price floor, I've cleaned up the graph a little bit to label the areas. When there's a price floor, the price is actually $3, which I've labeled here. Therefore, as you can see, the producers receive a lot less surplus. They're only selling, for one, 10 million gallons now. They're no longer selling 12.7 million gallons. And they're only getting $3 a gallon, so their surplus has shrunk to that smaller triangle. The consumers, at least who are buying the 10 million gallons, are getting more surplus because they're now paying only $3 instead of $3.67. So to look at the area between the demand curve and the price of $3, now we have two shapes. We have to add the triangle and rectangle. And again, those who are consuming the 10 million gallons are certainly happier. However, you may notice that we're missing an area of welfare. The part that I've labeled DWL, which stands for deadweight loss. That's what we call that surplus that nobody gets anymore because the government interfered with the perfectly competitive market. Those $2.7 million of gallons that are no longer being sold are creating surplus for neither consumers nor producers. So there's a loss of happiness for the consumers that would have purchased those gallons, and there's a loss of surplus from the producers who would have sold them. So producers are definitely going to be worse off here. You can see their surplus is less. Consumers may be better off overall. It depends on if their gain from saving money is greater than the loss of not consuming as much. So for them, it depends. But overall, the market loses. The deadweight loss is, again, surplus that nobody is getting, not even the government. There's also questions here of equity. Who is getting this 10 million gallons? Is it all consumers? Is it those that show up early? Something we're not calculating in here is how long in line do you have to wait? Time is a cost, right? So they might only be paying $3 a gallon, but if the lines are around the block, you might be paying $3 a gallon in 2 hours of your day. But we can calculate for this function exactly how surplus has changed because we have equations describing supply and demand, and we can solve for those points as I'm showing you here on the graph. For consumers, we'll have to add a triangle and a rectangle. For producers, we just have a smaller triangle. We can get the deadweight loss by subtracting the total surplus from what we had before, or you can simply solve for that deadweight loss triangle by itself. I'll do the first way, and why don't you do the second way and see if you get the same answer. So after the price ceiling, the triangle we'll be calculating, 1/2 base times height for the consumer surplus, is 1/2 times 10 minus 5 times the base of 10 now, because again, remember, we're only purchasing 10 million gallons. Then we add the rectangle, which is described by the base of 10, the height of 5 minus 3, or 2. When we add all that up, we get an area of 25 for the triangle, an area of 20 for the rectangle, or $45 million of surplus. So it looks like here, for this function, consumers are better off overall. But again, we don't know which consumers got the gallons of gasoline. There may be one consumer who's not getting any now. This is not talking about how evenly distributed the benefit is. And if we're taking this model to be very accurate, the consumers who aren't getting the gasoline are those that aren't willing to pay as much because they're on the lower end of the demand curve. Now, if this was the government trying to help out working class individuals, you might think, well, the people who are willing to pay the least are probably those who can afford the least, and so this is actually hurting a segment that the government was trying to help. This is a common result of most government policies, to be honest with you. But overall, if we value everybody the same, it looks like the consumers are better off as a whole. For producers, we just have a smaller triangle to calculate, so 1/2 times the base of 10 times the height of 3 minus 0.5, or 2.5, and we get $12.5 million of surplus for the producers, which is definitely less than before. So the change in consumer surplus is positive 4.8, the gained surplus. Producers lost $7.63 million of surplus compared to before the price ceiling. So overall, the change in total surplus is the gain for consumers minus the loss to producers, which gives us negative $2.83 million. This is the total amount of happiness in the market that is gone in dollar amounts due to the government intervention of the price ceiling. This is the deadweight loss. Again, you can calculate the triangle of the deadweight loss by itself as just that area. You should get the same number. So although it seems that a lower price of gasoline might be beneficial to consumers, here it turns out it was. But we did see there was an area of consumer surplus loss to deadweight loss, and actually depending on the demand curve, we might see a situation where consumers are not benefited overall. Second, although we saw a benefit overall to consumers, we don't know which ones were benefiting. There may be some that completely lost surplus, and were unable to buy any gas at all. Without more details to our model, we can't really say who's getting the benefit and who's getting the pain from the consumer side. But a price ceiling is not the only price control government has. It can also institute what's called a price floor, or a legal minimum that may be charged. So let's think of an example of putting a price floor on agricultural goods like corn. Here I'll be using the supply function 1 plus 1/5 QS and the demand function 8 minus 1/5 QD. So again, it'd be good for you to check the graphs that I'm making, see if you can draw them yourselves, and solve for the equilibrium on your own. The price floor we're going to set is going to be $6, let's say a bushel of corn. So that'll be the minimum you can charge, which would be a really high price in reality. Well, in this case, we would have a competitive equilibrium, absent of the price floor, of $4.5 a bushel and 17.5, let's say, million bushels sold. If the government instituted a price floor of $6, that would mean you're not allowed to sell the bushels at $4.50. You must charge $6. Well, what's going to happen in that case? If you see where $6 intersects with the demand curve, you can see that the consumers would only demand 10 million bushels if the price were as high as $6. The suppliers would want to supply 25 million, but the consumers wouldn't buy it. They would only buy 10. So we would have an excess supply in this case. Because the government is trying to artificially prop up the price, the producers would oversupply the market. And we would be left with a surplus amount of corn. But notice that even though the government is pushing up the price, we still have the same outcome qualitatively that we did with a price floor, which is less units are being transacted. Here we go from 17.5 million to 10 million. So regardless of whether it's a floor or a ceiling, if it's binding, if it's changing the market, we will have less transactions and we will have a deadweight loss on those transactions that didn't occur but would have absent government interference. So once again, it's possible we can calculate the change in consumer and producer surplus. As you can see here, the consumers will definitely lose in this case because now their surplus is represented by this smaller triangle. They're only buying 10 million bushels, and the height of the triangle is 2, the difference between 8 and 6. Whereas before, the height was the difference between 8 and 4.5, and the base was 17.5. So their surplus definitely shrinks when the price is artificially pushed up. That makes sense. The producers may be better or worse off overall. It depends. Before they were getting this triangle here, the difference between the supply curve and the price of $4.50. However, now they're getting $6 a bushel, but only selling 10. So this rectangle here represents a surplus that they didn't have before. So it's a gain. However, this little triangle here represents the surplus they lost because they're not selling those units anymore. So whether or not they benefit depends on if the gain is bigger than the loss. Here, just visually, it looks like it is. But you'll be able to check this on your own. I've given you all the points here. See if you can solve it on your own and tell whether or not producers are better off overall. However, one thing that is certain is that the market itself is worse off because, again, we have this deadweight loss and nobody is getting this surplus at all. So what's happening here is that producers are gaining some surplus from consumers and then they're losing some from not selling as much. Consumers are losing surplus to deadweight loss and to producers. Now, I'd like to take a moment to talk about how agricultural subsidies actually work. So this is an example you typically see in most textbooks. However, the way it actually works is a price floor is guaranteed to the farmer, but the market doesn't have to pay it. So the way it would work here is the government actually allows the price to be whatever it is on the market. So it's free to go down to $4.50. However, if $6 were the price floor, and you're a farmer and you sold your bushels for $4.5, what you could do is go to a government office and they would pay you the difference. So they would give you an extra $1.50 for every bushel you sold because it didn't hit $6 on the market. Now let's think about that. How does that change things here? Well, if the price in the market were actually 6, we can say from this graph how much the farmers would want to supply. They'd want to supply 25 million bushels. So since they're guaranteed to receive $6, no matter what the market pays, overall they'll get $6. What that means is if the market price is ever less than $6, they're still getting $6. The government makes up the difference, so they're still producing 25 million bushels. What that means is supply should actually be a straight line coming out of 25 for all prices under 6. And then if price ever were to go above 6, this is what they would offer, the same as always. So this graph actually represents a more realistic version of the price floors or guaranteed prices that many farmers have access to. It changes the supply curve to be a vertical line. It guarantees the farmers will produce whatever is profit maximizing for them, given the price floor, if the price were to ever go lower, because even if consumers pay less, the farmers will get $6 at least from the government. Now, in that case, look where supply intersects with demand. What that does in the market is actually push the market price down from $4.50 to $3. So consumers are paying less, the producers are producing more, and if you think about it, consumer surplus is way higher in reality. Look at this. They get this entire triangle. They're only paying $3, they're buying more, they're definitely happier. Meanwhile, producers are getting $6 for each one of those bushels. So their surplus is this entire triangle, because the original line represents their costs or their willingness to accept. Now, this is kind of confusing because we have overlapping surpluses there, right? Where's this value coming from? Well, the subsidy is being funded by taxes. So we're pulling money out of other markets to pour more surplus into this one. So maybe now's a good time to look at, well, what's the effect of taxing other markets so that the government has revenue to pay for things like this? For the example of a tax, we're going to look at gasoline taxes. Now, that's good for two reasons. One, because it's easier for us to graph taxes if it's a certain dollar amount per unit. Now, most sales tax that you pay is a percentage of what you buy. When we tax gasoline, we don't do so according to the percentage of the dollar amount you spent. The gas tax is actually per gallon. And in California, we pay 53.3 cents a gallon. The tax per unit gasoline makes this a lot easier to model with equations here. Now, everything we're going to say here does qualitatively transfer to the sales tax you pay, which is a percentage of the price. It's just a lot easier to shift graphs by the same dollar amount per unit rather than a percent. But the question we haven't addressed yet is, well, who's paying this tax? Let's assume, to begin with, that the consumers are paying it. Now, this is not what we do right now, but we'll see how things change when we tax the producers. So what I mean by taxing consumers is, let's imagine that every time you buy gasoline, you have to scan some app on your phone that identifies you and tells the government how much you bought, and then the government demands from you a tax payment for every gallon that you bought. What would that look like? Well, we would expect your demand to shift down by the amount of the tax. If we have a 53.3 cents a gallon tax, your willingness to pay for gasoline doesn't change overall, but since you have to pay 53.36 to the government, your willingness to pay the gas station per gallon goes down 53.3 cents. So the demand that the gas station sees looks like a demand curve that has shifted down, because you're not willing to pay them as much since you have to go pay the government. So the difference between what you pay, including the tax, and what the seller receives, which does not include the tax, that difference is the tax. So there's going to be a difference in California of 53.3 cents a gallon. Here's the equations I'm going to be using for this example. Here's your supply curve. This is the demand I'm using. But if you have to pay $2 more a gallon, let's assume a $2 tax, something even, because doing 53.3 cents would make the math a little messy. So let's say $2 for this example. Your willingness to pay will drop by $2 for every gallon. So we'll subtract 2 from the demand equation, and you see the intercept falls by $2. So now we have 6 minus 1/5 QD. Now let's see what this looks like on the graph. So here's the original situation. As you can see, these are the same equations I used for the corn example, so we have the same numbers. But now we're calling it gasoline. So gasoline is $4.50 a gallon. And again, think about what these numbers mean. The height of the demand curve is the maximum willingness to pay for that unit of gasoline. So for the first unit of gasoline here at 0, before we buy any, the consumer willing to pay the most for gas would pay up to $8 a gallon. Well, how would that change if that consumer had to pay the government $2 for the gallon? They're still willing to pay 8 total, but now they'd only be willing to pay 6 at the pump, because then they have to go and give the government 2. That's like a shift in the demand curve. So here's the situation. I've labeled the demand curve starting at 6 dt for the demand with the tax. And the way to think about it is that's the demand curve the market sees. The actual demand has not changed. But when we look at the market, it seems as if consumers are behaving as if that's their demand curve. Well, what happens is the equilibrium price drops to $3.50 a gallon. The equilibrium quantity drops to 12.5 million gallons. So the gas stations are charging $3.50. However, we, the consumers, are paying more than that. We pay $3.50 at the pump and then an extra $2 to the government. So this is why economists often say that taxes drive a wedge between the price the seller receives and the price the buyer pays. As you can see here, the price the seller receives is $3.50. That's the new equilibrium price. But we as consumers are going to pay $2 more. We're actually paying $5.50. That $2 is going to the government. So once again, we have a drop in the amount of a good or service that's exchanged when the government interferes with the market. We went from 17.5 million gallons to only 12.5 million gallons. So that's a recurring theme of government interference with a perfectly competitive market. Taxes discourage behavior. If you tax something, you'll get less of it. Also notice that buyers and sellers share this tax burden. I said that we're taxing consumers. They're paying the $2 a gallon. But if you look at it, the price the consumer pays is $5.50. Before it was $4.50. So we would say that their tax burden is only $1. They're only paying $1 more per gallon. Meanwhile, the gas stations are actually sharing some of that burden. They were getting $4.50 a gallon, now they're getting $3.50. Even though they weren't the ones being taxed, they still have a part of that burden. They're getting $1 less a gallon. Now in this example, they're sharing the burden 50-50. They're both suffering $1 a gallon. That's just because of the functional forms chosen here. It's not always going to be 50-50, and we'll talk about that a little later. Lastly, there's a deadweight loss. Same as a price control. When you discourage behavior in a market, the welfare that was generated from that exchange is gone. Nobody gets it, not even the government. All right, well, let's switch it up, because this was kind of silly to think about, right? Why would they make us pay? In reality, the gas stations pay. What happens is we pay them for the gasoline. They're the ones that pay the tax on it. Let's see how this changes things. Well, now since the producers are the ones that have to pay the tax, you would think, okay, they're going to demand a higher amount for us. If before, say the first gallon the gas station provides us cost them $1 to produce for us, their minimum willingness to accept should have been $1. But if they have to turn around and give the government $2, they're going to ask us for $3, because now they need to cover that extra cost. Taxing the producers is just like raising the cost per unit by $2. That's all it does. Therefore, we should see a shift in supply. Supply should shift up by the amount of the tax, because that's the additional amount the producers need just to break even. The difference here between what the buyer pays and what the seller receives is the tax. We're going to pay a higher amount, but the seller doesn't get to keep it all. He has to send some to the government. So that difference is the tax amount. Again, we're using the same supply and demand functions, only now the supply curve is going to shift up by $2. Because again, this supply function represents the minimum willingness to accept, or the cost to the producer. And that cost just went up $2 a gallon. So we're going to add 2 to the original supply curve, and it's going to shift up. So here's the graphical representation of what we're talking about. I've labeled the new supply curve ST for the tax. And you may notice there's a similar story here. These numbers look familiar. The new equilibrium price at the pump is $5.50. However, the seller, that's what we're paying, the buyer is paying that. However, the seller doesn't get to keep it. The seller has to send $2 to the government, so now the seller receives $3.50. But wait a minute, isn't that the same thing that just happened when we tax the consumers? The answer is yes, that is exactly the same. Now look, the consumer's burden here is still $1. They're paying $5.50 at the pump. They used to pay $4.50. The producer's burden, again, is $1. They used to receive $4.50. Now they're receiving $3.50 after paying taxes. So nothing changes. What we realize here is that it doesn't matter who you tax. The consumer and the producers will share the burden, and the burden will be the same regardless of who you tax. So this is a good thing to remember. When politicians propose taxes and say, don't worry, we're not taxing the consumer, we're taxing the producers. It doesn't matter. We're going to suffer just the same. Many of you sell your labor services in the labor market. You might not think of it that way, but that's what's going on when you go to work. You're selling your labor services per hour. Now, when you get a paycheck, you might notice you have payroll taxes, Social Security, Medicare, Medicaid. There's a lot taken out of your paycheck, and that seems to be a tax on your labor. What some of you don't know is that the firm you work for also pays that amount. So whatever amount you pay, your company also pays that amount. Now, if I wanted to be a clever politician, I could say to the workers, hey, you know what? I'm going to get rid of your payroll taxes. I'm going to tax the company instead. It's their responsibility. They're going to pay 100%. But now hopefully you understand that that wouldn't change anything, because it doesn't matter who's taxed theoretically. The burden should be the same. And what would happen as a result of that is that your company would simply lower your wages because they have to pay more tax for you now. Well, so at this point you might be thinking, well, what is it that determines that tax burden? Again, I said it's not always 50-50. And the thing it actually depends on is the elasticity of supply and demand. How responsive we as consumers and they as producers are to price changes. People who are not responsive or flexible will suffer more. Which, if you think about it intuitively, that really makes sense, right? If we're very inelastic to prices and they change gasoline, if you have to get the same amount no matter what, then if taxes go up, you're just going to pay more. You're going to suffer more as a consumer. Let me give you an example. Let me show you. So here I've got a supply and demand curve, and I'm not saying which one shifts. I only have one supply and demand curve here. So regardless of which one we tax, you've just seen, we're going to have a price that the buyer pays, which is labeled PB for price the buyer pays, and the price the seller receives, which is labeled PS. And that gap, that difference, is the tax. And the burden for the consumer is the difference between the equilibrium price, which you can see with that dotted line, and the price they pay now. Now watch what happens if we make consumers inelastic, meaning even if the price of gas goes up, you're going to buy roughly the same amount because you have to get to work, you have to get to school, right? Let's see what happens. If I make this demand more inelastic, notice what happens to that burden. It increased for the consumer and decreased for the producer. And again, intuitively this makes sense, because if you're not going to change your behavior when price goes up, then you're going to be the one that pays more. Now let's push elasticity down. What if we're very responsive to price changes? You change the price of gas at all, we buy much less. Watch what happens to the share of the burden. We can shrink it to almost zero. If we're insanely responsive, if we're very elastic, then the producer is going to suffer all of that tax, regardless of who actually got taxed. Now let's look at it the other way. Let's say we're very inelastic and the suppliers are very elastic. In that case, you see their burden shrinks. So if firms are very responsive to the price and we are not, which sounds like the more realistic situation to me, at least in the short run, then even though the producers have to pay the tax, we're the ones that actually have the higher burden. When the taxes go up, essentially the prices we pay at the pump go up almost 1-for-1. So what this is demonstrating is that the burden depends on the elasticity, relative elasticity, right? It depends on who is more flexible to changes in price. Well, now that we understand the effect that taxes have on prices and quantity, let's take a look at welfare. Here we're looking at our example again, after the taxes, and we can see the change to welfare in these different areas. So before, when everyone was paying $4.50, and that's what the producers were receiving, the consumers got surplus area ABE, the area between $4.50, the price, and the demand curve. Now that there's a tax and we're paying $5.50 at the pump, we only get area A as consumer surplus. Likewise, the producers, or the sellers, are only getting $3.50 after they pay taxes, so they're only getting area D. Area B and C is actually the tax revenue. That's going to the government now. Because we have 12.5 million gallons being taxed, you see this is the base of a rectangle, and the tax amount is $2, which is the difference between $3.50 and $5.50, which is the height of this rectangle if you add B and C together. So this rectangle comprised of B and C is base times height. That's the area where the base is the number of gallons sold and the height is the tax paid per gallon. So that area represents the total taxes going to the government. B was taken from consumers, C was taken from firms, and once again, we have this deadweight loss area E and F. Nobody's getting this because those last 5 million gallons of gasoline are no longer being sold. So not even the government gets it. Now overall, is this worse for the economy? Well, for this market it is, because we're losing E and F. But we got to think about what's happening to B and C, the tax revenue. There could be an argument for the government taxing it this way if the welfare they generate with that tax revenue, whatever they spend that money on, if it provides more surplus than B, C, E, and F, which is what's being taken out of this market, then you might be able to say, well, this is a justification for the tax because they're taking that money out of one market and generating more welfare somewhere else. Now, of course, if that were possible, you would think a private market would be providing that service anyway, whatever it is they're providing. But there are arguments for why that may or may not happen with some of the goods the government spends this money on. You'll have to take public economics if you're interested in that. There's also another justification for taxing, in particular, the gasoline market, which you might learn about in public economics, as well as environmental economics. And that is there are costs in this market that we're not seeing on this graph. And that's the cost of pollution to people who might not be in this market at all. So in LA, we're breathing in pollution generated by consumers of gasoline and gas stations that you and I had nothing to do with. We didn't purchase that gasoline, but we have to breathe in the pollution. And this cost is not represented on this graph. So we do have a deadweight loss, E and F, from the decrease in transactions of gasoline, but there is also a benefit from decreasing the sale of gasoline, and that is less pollution. So to ask overall if this is harmful or not, if this is beneficial for the economy, we have to look at all aspects. At this level, we're just looking at the gas market by itself, and there's definitely a deadweight loss here. But that's something to think about going forward. Well, this brings up the question. Let's just play devil's advocate. It's difficult to see at this level, but there may be a justification for taxes. Well, if that's the case, what's the optimal tax? Again, we got to ask ourselves, well, what do we mean by optimal? Well, let's say just for this case, let's say we just wanted to maximize revenue. We want to raise as much taxes as possible as the government. Sounds a lot like California. Well, what tax should be charged? Should we just push them up as high as possible? Is there no limit? Let's go back to that Mathematica graph I showed you before to think about this. This graph is showing you the effect of a tax, and we were talking about the difference in the burden between consumers and producers. And now you understand that that orange area is actually tax revenue. That's the amount of revenue the government gets to take. Let's look at what happens to that revenue as we increase the tax. Well, as I increase the tax, notice what happens is the gap between the price the buyer pays and the seller receives increases. The tax increases. But the base, the quantity that we get to tax, decreases. And that's because as we tax more, less people can afford whatever it is we're taxing. Now let's see it the other way. If we tax less, you would think, oh, we'll have less tax revenue. But look, we are taxing less per unit, but more units are getting taxed. So the question is, what happens to this area? If I take the tax all the way down to zero, that area looks like it might be less. We might be losing money. But we can't tell until we actually calculate the area. But if I keep going, at some point quantity is going to reach zero. There is some point at which you're losing money by taxing more. Let's take a look at that. Well, the tax revenue is just the taxes per unit times the units that we're taxing. But as we increase tax, those units go down. So the question is, which effect is bigger, the increase in tax or the decrease in quantity? Again, at some point, that increase in tax is going to decrease revenue overall because quantity is going to zero. The change in revenue depends on the magnitude of each change. And by magnitude, I mean the size of the effect of increasing tax versus the size of the effect of decreasing quantity because you're taxing. So the relationship between the tax rate and the tax revenue the government collects can be thought of as follows. This is what's known as a Laffer curve, named after the economist with last name Laffer, Arthur Laffer. Now, if you notice, if the tax rate is zero, the tax revenue is zero. So we're starting from the origin there. Because if you're not taxing anything, obviously you're getting no revenue. As you increase the tax rate from zero to something positive, say 0.01%, I don't think people are going to stop buying goods and services because you tax them a penny for every $100 they spend. So you'll get some positive tax revenue. The revenue will be increasing with the tax rate. But at some point, there should be a tax rate where nobody buys anything. If I tax you 1,000,000,000% tax rate on anything you buy, you're not going to buy anything, at least not legally. And so there's going to be some point where the tax revenue is zero. We'll take that all together. If we're starting at $0 tax revenue, we're increasing with the tax rate, but at some point must go back to zero. That kind of suggests that we have a shape like this. So this suggests there might be some optimal tax rate if your goal is to just maximize how much money you take in taxes. And you might actually be at a point where taxing more will decrease your tax revenue. There's a top to that hill. Now, one other thing we might want to consider, though, even if we want more tax revenue, is that deadweight loss is going to increase exponentially with taxes. Now, why is that? Because the deadweight loss, remember, it's that triangle of surplus we're losing. We can measure that triangle as 1/2 its base times its height. If the tax doubles, let's say, the base of that deadweight loss triangle will also double because it's equal to the tax. But the height also will increase. The height will be the decrease in the quantity. So that is, if tax doubles, deadweight loss increases by more than double. Now let's take a look at that. Returning to the example, the deadweight loss is this purple triangle here. And if we look at it, this is a triangle turned sideways. This is the base, which is actually the amount of the tax. The height is right here. We can look at it as this line coming through the triangle. And that's the difference between where quantity would be and where it is with the tax. Now watch what happens as I increase the tax. Let's go to a tax of 0 almost. As I increase this tax, that base is increasing the same amount because look, this is the tax. As this increases, it increases the base because they're one and the same. But the height is also increasing. So that area is increasing faster than the tax itself. So a good representation of this in graphical form is as follows. As the tax rate goes up, the deadweight loss increases even faster, or exponentially. So these are two things policymakers need to think about when they set taxes. One is there is a rate at which you're actually hurting yourself in terms of tax revenue collection. You're going to collect less taxes if they're too high. 2, there's an exponential cost in terms of welfare or surplus as you increase the tax rate. But to get a real full view of these kind of policymaking decisions, I would suggest looking into taking public economics, which is a great course, sometimes called public finance. So hopefully you've got all those learning objectives achieved. You should know the effects of price controls, both a price ceiling and a price floor. You should understand how taxes affect price and quantity. Prices go up, quantities go down. And regardless of who we tax, the burden is shared. And you can see how that tax burden is split by comparing the difference between the equilibrium price and the price the buyers are now paying with the tax, or the price the sellers are receiving with the tax. And that gap is what we call their burden. And as I showed you, what determines who shares the majority of that burden is actually not who is taxed, but how elastic they are to price changes. If you're not very responsive to price changes, you're going to end up paying the majority of the tax, regardless of whether or not the tax was placed on you.